to our Building Better Basics with Sarah Leakey, who is the Numeracy Development Officer for Highland Region. This session is being recorded just now, but if you've got anything you want to say, pop it in the chat room and we'll do as best as we can. Thanks, Sarah.
Brilliant. Thanks very much, Karen. So as Karen said, the session's on Building Better Basics. My name's Sarah Leakey and I'm the Numeracy Development Officer for Highland Council. The session itself will look at this better basics through the context of multiplication and division, but I want to emphasize that all the ideas can be applied to other areas as well. It's just easier to sort of do it, focus on one thing at a time through the presentation. So the aims of the session will be to consider what the starting point is. We'll look at making strong foundations and kind of making sense of the maths, looking at reinforcing fundamentals, so developing fluency, supporting retention, and then look at long-term learning, including application of things that pupils have learned there. So the point of including this what's your starting point is certainly from in my early teaching career, I used to do a lot of the things that I'm going to mention here, but I would get quite frustrated with my own teaching in terms of pupils not really kind of making sense or understanding kind of what was going on. They would struggle to retain multiplication and division facts and things like that. So I would imagine there's still lots of people who have these types of starting points, and hopefully the presentation will explore some ways to think of that in a different kind of way. So games are frequently used to support pupil learning with multiplication and division. So things like this 4 in a row game, roll 2 dice, multiply the 2 numbers together, place a counter over your numeral, or something like this. I just took a screenshot of this from a website. So pupils are given these abstract expressions and they just have to sort of work their way through the game board, or something like bingo. So these are often your kind of types of things that are quite prevalent in classrooms all over the world. The issue with them, though, is that they're quite abstract. You know, it assumes that pupils already understand what multiplication and division is. And the same is true with things like times table games. So if I Googled times table game online, and the first 3 websites that came up, they had a total of 15 or more games, but they were all abstract. They all kind of assume that pupils already understand what multiplication and division is. So on one of the games, I also spent 3 times as long racing a car as I did actually solving problems related to multiplication and division. So the question is, are these games and activities really supporting our pupils to understand if they haven't got that foundation in place already? So just kind of thinking about that point about enjoyment versus understanding, because those games are often used because we want pupils to kind of enjoy maths. And I agree that learning should be fun and engaging, but I don't think that needs to be mutually exclusive or come at the expense of high quality learning and rich discussion. I think you can have both. If kind of moving into upper primary and into secondary school, you frequently see these times table grids. So pupils are taught how to solve problems like 6 times 7 just by sort of following the grid. And the question is, does it help them to find the answer to that problem? Yes. So this is why they're often used, because if pupils haven't managed to understand or make sense or kind of learn their times tables facts, then that's why pupils are given these. But my question is, you know, does this enable pupils to actually make sense of multiplication? What about division and its connection to multiplication? Can they see that through this table? And does it support them to build connections to prior knowledge? And how easily are they going to be able to apply their understanding to something like algebra if this is kind of the main way that they're accessing times tables or multiplication facts? So while they might be able to get the answer to the question, all this other stuff is kind of lacking, I think, in these types of representations. These fact family triangles are quite a popular one as well. I see them recommended quite frequently on kind of Facebook pages and things like that. And so pupils are taught that they can kind of generate these fact families from the triangle. But then my question is, what about problems like this? You know, they may be taught, right, 6 times 7, but can you do that the other way around, 7 times 6? And you happen to be able to do that because of the commutative property of multiplication. But by that reasoning, would a pupil also think that you can go from bottom to top? If you can go from left to right and right to left, and you can go from top to bottom, why wouldn't you be able to go from bottom to top to get these two representations? And it's very difficult to explain to a pupil with just these abstract representations why that isn't possible and why that doesn't work. So again, the question is, does it help them find the answer? Yes, to that specific question. But does it enable them to make sense of multiplication and division? How easily are they able to apply that understanding to other things related to fractions, situations involving rate and algebra? And my argument is that these types of things don't enable our pupils to do that unless they already have that understanding in place. Another one here, just in terms of learning intentions, success criteria, and the use of number lines. I want to kind of state from the start that this is not what I'm recommending a learning intention and success criteria should look like. I have done things like this in the past, and this type of thing, I did a Google search recently for this and found a very similar example on at a organization that does professional development for teachers and teacher training. So let's imagine the learning intention was, I'm learning to solve division problems using a number line. That's very specific to start off with. And then the success criteria, you often see things like this. I can put the number I'm dividing at the end of my number line. I can keep subtracting the number I'm dividing by until there are none left or there is a remainder. I can work out how many groups I've subtracted. So if we apply that to a problem like this, 80 divided by 10, and follow those instructions, I'm putting that number at the end, and then I'm subtracting 10 until I've got none left. And then I can work out how many groups I've subtracted. So if a pupil doesn't already understand multiplication and division, and they're just following this sort of recipe type procedure, then you can understand why lots of pupils make mistakes with this or aren't able to kind of apply their understanding to other contexts, because this doesn't really make a lot of sense. You know, where is the understanding here of, in terms, you know, for a pupil that doesn't come with the background knowledge that we do as adults, you know, why am I subtracting 10? It says divide by 10. So does that make sense? And also, where's the answer? There are lots of numbers in this number line, but there's the sort of answer itself, it doesn't appear to be there. And in this particular case, it's the number of jumps. But had this problem been slightly different, it wouldn't be the number of jumps anymore. But if I've just got this sort of recipe procedure type thing, I'm going to have to learn an awful lot of those to be able to do this in all possible situations. We'll revisit this again in a moment. So the rest of the presentation is going to be trying to look at how we can aid understanding and enjoyment through a process of making sense, developing fluency, and application. So I put this diagram together as it kind of helped my thinking about how I've sort of evolved in my thinking about this from the sort of reading and research and kind of work with children and so on. So at that making sense stage, we're using context that pupils can relate to. So things like story problems and counting collections. I'm not going to go into the ins and outs of these just now, although my colleagues are over in another room at the moment doing a session on counting collections. So I recommend you access the recording for that. And we're also going to, at this stage, you're looking at building mathematical language, developing understanding of mathematical properties, and that might be implicit or explicit. We'll look how even pupils as young as P1 and P2 can be developing these mathematical properties, and look at exploring patterns and relationships. At this developing fluency stage, just to kind of clarify what I'm meaning by fluency here, we're looking at flexibility, appropriate choice of strategy, or sometimes this is known as choosing wisely, efficiency, and accuracy. So yes, it's about kind of, you know, it's important and useful for pupils to have quick recall of these multiplication and division facts, but that alone isn't enough. They need to be able to understand them and use them flexibly, apply them to other problems. So everything that we did at this making sense stage can still be used here, but we're also using increasingly abstract representations, developing relational thinking, using this sort of true or false or sometimes always never type questions. And card games and those other abstract games might be appropriate at this stage, but after pupils have made really good sense of the learning. And we're going to look at supporting retention here as well. Once we get onto this application phase here, then everything at that making sense stage and the developing fluency stage also apply here. But the pupils are now starting to apply the knowledge, this stuff that they just know now, to new contexts and unfamiliar problems. I then put this kind of diagram that I created into these sort of cogs to try and emphasize the fact that this is quite a fluid process and there's many levels operating at once, and I'll illustrate that as we go through the presentation. So let's start off with just this making sense phase and looking at the contexts for multiplication and division. Multiplication is often explored through a one-to-many relationship. It's often explored through repeated addition rather than these one-to-many relationships. And so the research would suggest that using one-to-many relationships will actually support pupils' understanding of multiplication in a much better way. In terms of division, there are two types of division: grouping division and sharing division. And I don't think pupils are often aware of this, and often in the CPD that we deliver, teachers often aren't aware of this difference either. So just to exemplify these, multiplication might be 1 pack has 10 sweets in it. How many sweets are there in 8 packs? The grouping division, there are 80 sweets. They're put into packs of 10. How many packs are there? And that sharing division, we've got the same numbers involved, but the problem is different. There are 80 sweets. They're shared between 10 people. How many sweets does each person get? So in this multiplication problem, we know the number of groups. We know the amount per group, so 10 per pack. And we're trying to work out the total number of sweets. In the grouping division, the number of groups we've got is unknown, but we do know the amount per group, and we know the total number of sweets. And in this sharing division, we know the number of groups, but we're trying to work out the amount per group, and we can do that by knowing the total number of sweets as well. So just to illustrate this point, and this is the type of thing that I would be doing with my kids, but letting them explore it and sort of problem solve it themselves, rather than kind of teaching them quite explicitly. So I've just put this diagram together to illustrate the difference between these two, not as a model of how I would do this with pupils. So if you imagine 80 sweets, and it says they're put into packs of 10, so you can imagine pupils pulling out a group of 10 each time, and then seeing that actually that would produce 8 groups there. With this sharing context, that 10 means something different. Here it's how many groups there are, how many sharers there are. And often when people are kind of at the early stages of division, or those that have kind of struggled in the longer term, they'll start sharing these out one at a time to each group until they've got none left. So you can see that although the numbers involved in both problems are identical, and they're both about the same context, actually what's happening is very, very different. So if we go back to this number line that we had here, is this, and this is a sort of rhetorical question, is this grouping or sharing? So you could make an argument for both. However, given that we're kind of subtracting groups of 10, then it seems to be kind of more closely linked to the grouping. So dividing by 10 isn't sharing between 10 people, but it's taking out a group of 10 at a time. And so by linking it to kind of experiences like those ones we just saw there with the sweets, pupils can actually make sense of what this means, as opposed to just sort of following this number line procedure, for example. So we've got that question there. Are teachers aware of these differences? Are our pupils aware of the differences and the connections to multiplication? And are they taught alongside one another, or is this happening in discrete blocks? By starting with this, by telling pupils which strategy to use and writing out a recipe, my question is, are we supporting pupils to get an answer, or are we supporting them to actually understand the problem? And by putting those restrictions on, by saying you are using a number line, or you are doing this by subtracting groups of 10, repeated subtraction, are we allowing them to understand and explore mathematical properties and relationships, or do we limit this as a result of these kind of things that we're imposing on them? I get we come across lots of secondary pupils who state to us that they don't understand division at all, and they didn't really do it in school because they didn't really get multiplication, so they didn't move on to division. And I would argue against that. Use the two things alongside each other. Pupils don't need to know all their times tables facts in order to solve division problems. So there are other contexts for multiplication and division as well. So Cartesian products, arrays and area, scaling. And again, are we giving our pupils opportunities to broaden their understanding of multiplication and division through these contexts, or are they just limited to thinking that it's repeated addition and nothing else? These books are quite common into P1 and P2 classes, and pupils are given them and then they work their way through the book. And my question here is, does this promote answers, or does it promote understanding and rich discussion? And what we find with pupils that tend to use these books is that they tend to just continue to count in ones and not really move on from that. They might start counting in 2s and 5s and other things, but again, their thinking is limited to this sort of skip counting and not a huge amount more. And then by secondary, we see pupils still using these same strategies, which are quite inefficient. So I'm going to suggest that we use fewer questions, we make more deliberate choices about the number range that we're using and the succession of problems, and we try to use this to develop richer thinking and give plenty of opportunities for discussion. So I'll just give you a moment to read the questions on here. I'm not going to read them out to you, and just look at the number range as well and think about why those numbers have been chosen. So you might have noticed that, the number choice is quite deliberate. This was, I should say, this was questions that were given to a P1-2 class in a project that a colleague of mine was recently doing. So the 3 cars, 4 people, 6 cars, 4 people, so double the number of cars now, and then 7 cars, 4 people. There's one more group of cars in this situation. This was the next, and that's the only questions they had in that session. And then 4 cars, 5 people, 8 cars, 5 people. So you've got this doubling happening again here. And then this was one group fewer now. And then over here, we've got 8 pots, 2 pencils, 8 pots, 5 pencils. And then the final problem was actually a sharing division problem to see how they approached that. So I'm going to show you some of the work that they produced during these sessions. All the pupils, when they first started doing this, they were all counting in ones to solve the multiplication problems. Some of them knew how to count in 2s, but they weren't applying that to these problems. So we're going to pick up on this in session 3, and this was session 3 of a total of 6 sessions. So the pupils were given the problem, they were left to solve it independently, they didn't have any help on that, and then they came back together, and then the pictures were used as a discussion. So, sort of 20 to 30 minutes discussing the ins and outs of what they'd done, why they'd done it, why they made those choices, and making connections between different ways that pupils had solved the problem. And it's that discussion part that helps to move the pupils on to using more efficient strategies. So you can see this pupil's recording here. They've drawn the cars and then they've used buttons to represent the people. But what I really like here is that you can see the progression in the organization of the materials. So this was just with this progression here. So they've moved from just kind of lining them up to actually putting them in the groups of 4. So they're much more likely to start seeing connections between counting in 2s and connections between 2s and 4s and so on. This pupil here, they started counting in 1s, but then realized actually it's quicker to count in 2s, so they changed. And then for this part here, so we were now 6 times 4, They didn't start the whole problem again. They just added on another three groups of 4. However, when they solved the problem to work out the total, they did start back at 2 again. So 2, 4, 6, and so on. And then here they just added on one more group, but then they started their count at 2, 2, 4, 6, 8, and so on. So some really good thinking here in terms of understanding that actually I don't need to start all the way from the beginning. I can just add on one more group, but limitations in terms of still needing to do that count from the beginning again. This pupil here, you can start to see them using facts that they know. I know 2 times 4 equals 8, and then they counted on. For this next problem, 6 times 4, they went and counted in ones, keeping track on their fingers. But what was interesting was this next problem, 7 times 4, they didn't start from 1 again here. They used their answer to the previous problem and then counted on. So this is much more sophisticated thinking. And I think with those workbooks and things like that, the questions aren't necessarily deliberately set up to promote this type of thinking, so pupils don't use it. This pupil here, this was for 4 times 5. They started drawing it out, but then they realized, oh, actually, I understand what's going on here. I don't need to draw all this out. I can just count in 5s, and they recorded that there. So remember, these are P1 and P2 pupils, and they were all counting in 1s to begin with. And then they wrote a little explanation about what happened for this next problem, 8 times 5. I used my first page to work out this answer by counting on like this, 25, 30, 35, 40. And then for that next one, 7 times 5, I knew if I counted back 1 car, the answer was 35. So they're thinking about adding groups and taking away groups rather than starting from the beginning each time. This one here, they organized them in the groups. They've recorded it in an equation here, so you can start to see the links between the materials and the more abstract thinking. They couldn't count in 5s, but they have used this rhythmic counting, so they're beginning to get the structure of that 5s count. And then this one here, again, the progression and recording is quite nice. They started by drawing the people, 5 people in each car. And then for this one, they moved and just thought, okay, actually, I don't need to draw all these people out. I can just represent those by dots. And they've used a dice pattern there. What was interesting about this pupil is that rather than counting in 5s or 1s like some of the others have, they put these 2 groups of 5 together to create a 10. So they counted 10, 20, 30, 40. So here we've got the beginning of these doubling and halving relationships that you often wouldn't expect to see until maybe pupils were a bit older. But because pupils have had opportunities to make sense of this themselves rather than strategies imposed upon them, and they've had opportunities to kind of time to think and time to draw what's going on, they're more likely to make these connections. So this one here, 7 groups of 5, they did start from the beginning again, and they counted in 10s again, 10, 20, 30, and then they just added on another 5 there. This pupil, they just knew the answer to 4 times 5, so they've got that as a fact. They don't just know the answer to 8 times 5. They haven't made the link between the doubles, so that might be something that kind of comes out of that discussion perhaps, but they have used a really sophisticated strategy to work this out using other facts that they know. So 10 times 5 equals 50, and then they subtracted 2 groups of 5. And again, if any pupils didn't understand what had gone on with this, you can start to use other pupils' drawings to make sense of other people's strategies so they can link it back to something that they can actually see rather than just something that's abstract. This pupil doesn't need to draw this out because they've got other knowledge that they can use. But we can use the drawings if we need to from other pupils. The equation isn't written quite correctly here, but I don't think that really matters. The pupil is P2 and this is quite sophisticated. And then for 7 times 5, he just knew that answer as a result of the previous question. For this one, I'm just going to talk about the division problem. So the pupil here, so the problem was 80 divided by 10. So the pupil's got 80 pieces of pasta to represent those pens, and they've got 10 cups to represent the pencil pots. And then they organised these in fives. They decided that that would kind of help them see how many were there more easily. And then what they did was they put 5 in each cup, so you can see them in the cup there, and then saw what they had left. So they've got 30 left in here. And again, if you think about where this is leading to, this is chunking or kind of the beginnings of long division, but in a primary 1 or 2 pupil. But they're actually making sense of what's going on first. What they did then was share 1 per cup and then they kept doing that until they had none left. And I like the fact that they've put them outside the cup so that they can see more easily how many are going in. And based on these visual representations, when you're in this discussion phase and sharing this with these other children might start to notice other things, bring in other facts that they know, and start to build other connections. And then they've recorded it here. So they've said this is actually an adult's recording, but of the child's thinking. So they said there were 5 pieces of pasta and 3 pieces of pasta. And so that represents 8 pencils in each pot. So again, really sophisticated thinking. And this isn't kind of, I don't want people to think that we've sort of picked an exceptional kind of P1 or P2 class. Remember, these kids were all counting in ones to begin with. It's a result of the way these problems are set up, the choice of the questions and that discussion phase, along with sort of other things like choral counting that are built into the sessions. So this pupil here, for the 8 times 2, they counted in 2s. For the 8 times 5, they counted in 5, skip counted, and they couldn't do this before. This was the kid that was rhythmic counting. They had to count from 1s before. And then for this one, I'll briefly describe this because it was really nice what they did. They started by sharing 3 in each pot, and then they realized I can't count in 3s, so I'm going to add an extra 1 to each one, and then I'm going to count in 2s because I can do that. So they counted in 2s up to 40. And then they knew that they had some more to put in. So they put another 2 in each and counted in 2s from 40. So 40, 42, 44, and so on. And then when they got to 60, they knew they had some more. So they put another 2 in each and again, continued that count. They didn't need to start from 1 again, which was what they had been doing previously. So this final one here for these P1 and 2 strategies is this one here I wanted to draw your attention to. They've drawn them out in 5s, but again, this kind of relational thinking is really, really nice. So they've seen that 2 5s actually makes a 10, and so they can count in 10s instead. And that's much more powerful coming from this point than just telling pupils, oh, you can halve that number and double this number and it'll give you the same answer. This pupil has done that themselves, and then that can be shared with the other pupils to help them make sense of it. So coming back to my diagram here and kind of thinking about how that works with the sort of this cogs idea, if we take this pupil's work here, we can see that the overall kind of aim of doing this was to help the pupils make sense of multiplication and division. So we're at this making sense stage here. A lot of the focus was around 2s, 5s and 10s. So we're maybe starting to make sense of times tables facts related to 2s, 5s and 10s, but we haven't told the pupils, you know, we're learning our 2, 5 and 10 times table. It's coming out quite naturally as a result of this. Lots of them are now at this developing fluency stage for skip counting in 5s and 10s, whereas, you know, at the very start, they might have been more at the making sense stage of that. And then we can see certain things being applied here. So when they solved this problem here, they solved that as 30 plus 5. They knew that. So that was an application of their place value knowledge. And then just thinking about the future implications. Why is all this stuff important? Why wouldn't I just teach them kind of algorithms or something like that? But as I said, this is building the foundations for later learning. So if we think about the future implications of what this might lead to with more experience, more practice, pupils start kind of condensing their recording, making other links. So their thinking is linked to solving problems by splitting one of the factors multiplicatively, and the doubling and halving strategies. So instead of 8 times 5, thinking of this as 4 times 2 times 5, and then regrouping that 4 times 2 times 5. So we've got 4 times 10. So again, rather than just telling pupils, if you halve this number and get 4, you need to double that number to get 10, you can make sense of that through this pupil's drawing. So this is linked to the associative property. I'm not going to go into the ins and outs of the properties, but I do have a document on the Highland Numeracy blog that explains these in a bit more detail if you're unsure of them. So moving on to the counting collections now. Again, I'm not going to explain the ins and outs of counting collections, but I'm just highlighting it as a useful way for pupils to make sense of their learning, and in particular make connections between addition and subtraction, multiplication and division, and so on. So one of my questions is, how often do our pupils actually get to experience and make sense of larger quantities? So I would question whether many pupils get the experience to count things beyond about 20, physically count them. And then once you get up to about 100, very few pupils have had experiences counting larger collections like that. It's beginning to increase with this sort of awareness of things like counting collections and the kind of value that it brings. But sort of traditionally, I would say that was less so. So this pupil had a collection of elastic bands to collect, and I should say as well, pupils find this immensely kind of engaging. We've seen pupils go on to sort of do this at home, and this includes in schools where you know, there is traditionally lower attainment or poorer attendance and things like that, or pupils are disengaged, and the engagement really goes up. So this pupil had a collection of elastic bands. They made an estimation first about how many they thought were there, and then they counted, and then they're encouraged to kind of look at their estimation in relation to their actual count. What they did was they had 5 of these little pots, and they started by putting 20 in each pot. They didn't have any more, so they got a bigger pot, and then they put 5 of those 20s into the larger pot. And you can see that on their recording here. So 20, 20, 20, 20, 20, and that's 100. And they did that 3 times. And then they've also got these 3 20s here, which is recorded there, and then this extra elastic band there. So they've got a total of 361. This pupil was at the really early stages of being introduced to counting collections. They've done a pretty good job here. Lots of pupils actually end up counting in ones, even if they're older. But you can see where this is going. You know, they'll start to just understand kind of facts like 5 times 20 equals 100. And the sophistication of the recording into sort of more formal notation starts to come out of this as well. This pupil here, he was working with a partner. They organised their sticks into groups of 5. Initially, they counted them in 5s to work out how many, and then there was an extra 2 on the end there. And then they realised they had 10 groups of 5, which was 50, and so they counted 50, 50, and 50. And you can see their recording in here. And then they've put that into a more formal equation at the bottom. So again, these particular pupils didn't necessarily record this using a multiplication symbol or anything like that, but you can see the sort of potential for how it could move to that and help pupils to start to make sense of those types of things. If you think of things like, you know, 3 times 50 equals 150, pupils often saying, oh, I just did 3 times 5 equals 15, and then I added a 0. You know, I don't think there's anything inherently wrong with that, because pupils will notice it, so they'll generate that themselves. My issue is when pupils are taught that as a strategy, but they don't understand, or they've got no other way to explain it. So I would encourage you not to tell your kids just to add a 0 on the end, because actually once you move into decimals, that doesn't help anymore. You can't stop pupils from noticing that, and it is an interesting observation. So rather than kind of drawing their attention away from it, you could use these collections to help explore and understand why that actually happens. We'll look at some decimal work in just a moment. So I'm going to take a bit of a pause from the counting collections to look at something called unitizing, and then we'll return to the counting collections in a moment. So this idea of unitizing is understanding that units can be made up in different ways. Again, lots of pupils don't really kind of understand this, particularly if they're kind of tending to use counting strategies, or they've just been sort of told procedures for working things out. But it can be, the sort of research has shown that it's really powerful, particularly in supporting pupils to understand and work with fractions and decimals. So I'm going to do this one in the context of fruit pastels. So, and I would emphasize that this is more just to sort of illustrate what unitizing is, not what I would do with pupils. So this is a unit of 1, and within a pack, I've got 12 units of 1. If I wrap those all up in a sort of fruit pastel pack like this, I've now got 1 unit of 12. So I can see that I can record this in 2 different ways. If I have 4 of those packs together, I've now got 4 units of 12. And if I wrap those up into a larger packet, I've now got 1 unit of 4 units of 12. So there's 3 levels of units going on within this. And obviously I could lay those all out like this and have all of the sweets individually as well. Same kind of thing with the drumstick example here, but now I've got 10 in a pack. And the purpose for picking 10 is that it leads really nicely into decimals, but actually helping pupils to make sense of this alongside other work. So if we view that pack as a unit of 1, then within that pack, I've got 10 units of 1/10. Again, I'm not suggesting you just tell pupils that. There's a lot of other work that needs to go into it. But the idea that I'm trying to put across is supporting pupils to see these as units in their own right. So one of those sweets could either be viewed as 1/10 of a unit of 1, or it could be viewed as 1 unit of 1/10. If I have 2 of them together, then I've got 2 units of 1/10. And if I view those as 1 unit, I've now got 1 unit of 2/10. So again, various experiences can support pupils to build up this understanding of unitizing. We see it all the time. Money is a good example. So a £5 note, for example, we've just got 1 unit of £5, and that's equal to 5 units of £1. And there's all sorts of ways we could decompose the £1 into units of different sizes as well. So going back to the counting collections then and trying to see kind of how that was all relevant, you've got some pupils here that were counting puzzle pieces. From a differentiation point of view, you might have pupils just counting that to identify how many in the collection, so each piece having a value of 1. But the pupil we're about to look at had assigned a unit value of 100 to each of those pieces. So he was unitizing there. And this is his recording. So each piece has got a value of 100, which means that 10 of them together have got a value of 1,000. So this whole top row here has got a value of 5,000. The next row has got a value of 6,000, but notice he's added this extra 200 on. That's because in one of them, there was 2 extra pieces. The bottom row has got a value of 5,000, and then we've got this extra 100 over here, and he's recorded that in an equation. What's really nice is what he goes on to do next in terms of formalizing this notation. So he moves from the informal to the formal. So we can see his recording here, and this draws out the sort of mathematical properties and relationships better, but it's all built through understanding. And for pupils that can't make sense of what he's done, you can go back to the concrete here as well. So this pupil hasn't been explicitly taught about brackets. Other pupils in his class have done some work on it. He's in a multi-composite, so he may have picked up bits and pieces, but this seems to be kind of just a natural extension of his thinking, using those brackets as a grouping symbol. So he's got 16 lots of 1,000, and then he's added on the 300 at the end. There's another example here. These pupils had some pieces of pasta in their bag to count, and they decided to organize them with 5 in a cup, and then they've put them in these columns here. Now, again, from a differentiation point of view, some pupils might have counted this in ones and just found out how many pasta pieces in the collection. This particular pupil happened to assign a unit value of 0.1 to each piece of pasta. This pupil does understand decimals, so that kind of made sense to him. He was able to work in that kind of abstract way. If that didn't make sense to pupils that are at the early stages, then you could do it with something that was kind of more, that made a bit more sense. So for example, like those drumstick sweets we saw before, that made sense as to why they might have a value of 1/10. So this was their recording for what happened. They said each piece of pasta is worth 0.1, so each cup is worth 0.5. And then there were 10 cups in a column, and in that final column there were only 9 cups. And you can see they're recording here 0.5 times 10 equals 5. They've got that 3 times. And again, lots of, so here that adding a 0 doesn't work anymore, which is why I'm suggesting we don't go down that route. Pupils might say, oh, I just moved the decimal point. But how's that going to help this pupil do multiply by 9 if their only kind of way of multiplying and dividing decimals is things like moving decimal points and stuff like that? But you can see this pupil and their explanation alongside it was quite clear and quite sophisticated. They used their answer to 0.5 times 10 equals 5, and they knew it was one group of 0.5 less, so they just took off 0.5. So some really nice thinking going on there as well. And for any pupils that didn't understand this notation, because this is all here, you can go back to that and make sense of it. Incidentally, another pupil sort of saw this in a different way. They decided to say, right, 0.5 plus 0.5 is 1, and then there's another one here. So each of these rows is worth 2, and then they went on from there. So we're going to move on now into looking at kind of patterns and relationships, again from a making sense point of view, and incorporating some data handling as well. So you might have a situation like this where you've got some objects like this, and you're getting kids to sort them into a Venn diagram. And after they've been given some opportunities to sort them, it will probably look something like this, unless they've made some mistakes, in which case that's an opportunity for discussion. And I want to emphasize here that this is much more than just a sorting activity. If you just get them to sort them and then kind of that's it, then there's only so much they'll take from it. But if you use it as an opportunity to begin to support pupils to make conjectures, generalizations, predictions, have discussions about the reasonableness of their solutions, they can learn so much more from it. So you'd be asking them things like, what patterns and relationships do you notice? So they might say they're all even numbers. It went in turn. 2 was only a multiple of 2. 4 was a multiple of both. 6 was only a multiple of 2, and so on. But then building on that further, can they work out why this is happening? All multiples of 4 are multiples of 2, but not all multiples of 2 are multiples of 4. Can they generate these sort of generalized statements? And then things like they might notice 2 was only a multiple of 2, but 12 was a multiple of 2 and 4. I wonder if 22 will only be a multiple of 2 again. So people start to generate questions from things that they've noticed. And then making predictions. Will 42 be a multiple of 2, 4, or both? And how do you know? Or a similar question, is 42 exactly divisible by 2 and 4? And how do you know? And then looking at the reasonableness of their solutions. So Sarah divided 56 by 4 and said the answer was 13. Without working it out, are they right or wrong? And how do you know? So you can do a similar sort of thing with Carroll diagrams. We're slightly more abstract now, not necessarily using the sort of concrete materials. But what I want to point out here is, again, looking at patterns and relationships that they might notice, but also kind of starting to make sort of conjectures and stuff. I don't think there'll be any numerals that go in the column is not a multiple of 5. Can they explain why? I've noticed that every other number is a multiple of 10. And again, can they explain why? So allowing plenty of opportunity for this and discussion alongside it. You can also pose quite challenging questions that pupils will make sense of if they've had time to explore this in detail. So if I divide 385 by 5, will the result be an odd number or an even number? If that's too challenging, you might start with a lower number, or you might have a few different examples so that it's accessible if you've got quite a broad range in your class. So we're just going to move on to some relational thinking now, and this could be at that developing fluency stage, or it could be at this sort of long-term learning and application stage. And pupils are now using their mathematical reasoning. It's really important with these types of questions that the focus isn't just on getting an answer, The point of doing this is, yes, figure out the answer, but then figure out what's going on. So you need to have an idea of what mathematical property am I trying to get the pupils to explore and understand by posing these questions? Why have I picked this sort of sequence of numbers? And all the story problems and things like that, the counting collections are really useful. They help pupils to see some patterns and relationships and mathematical properties. But sometimes just putting them in a sequence like this with more abstract things can help them to see things that aren't as easy to see in those situations. So you've got more examples here. I'm not going to go through each of these just for time, but you'll see them on the slides afterwards. But think to yourself, what's the point of posing these? What mathematical property or understanding am I trying to get at here? And I also want to look at this one. So this might be a sort of more traditional question that pupils are posed. Can you use this to work out this? And if pupils have kind of, even if they don't understand inverse operations, but they've been told kind of how to do this, they'll be able to get an answer to that. But if you want to really kind of test their understanding of these properties, a question like this is probably much more interesting and will kind of check that deeper level of thinking. It came from a Key Stage 2 maths test. I'm not a big fan of the SATs tests, but this question was particularly nice. So the question was 5,542 divided by 17 equals 326. What's 18 times 326? So they need to use the idea was they didn't start from scratch, but they used their knowledge of the answer to this problem to work out this one. And it adds an extra layer of complexity compared to that one in blue. Okay, I'm very conscious of time, so we haven't got too long left, so I'll just kind of briefly say some of these other bits and pieces. So these are known as think boards. This pupil is solving 47 times 3. They've used 2 different strategies. Here they've split the 47 into 4 10s and a 7, and here they've used rounding and compensating, so 3 times 50 minus 3 times 3. But again, I want you to think about, where's that going? Some people kind of say like, oh, why are we getting our pupils to do all this long, complicated stuff? This builds on all that other understanding with the pictures, but it's more formal recording now, but from a sense-making point of view. And it can lead into kind of understanding things like making sense of multiplying out brackets and stuff, rather than kind of just teaching children to draw arrows between stuff. And again, all this stuff has kind of underlying mathematical properties behind it. And again, just to sort of illustrate this point, we've got multiple levels going on. So developing fluency, I might be kind of developing fluency with multiplying 2-digit numbers by 1-digit numbers. I might be applying strategies used with simpler problems to these more challenging problems. And I'm going to be applying known multiplication and division facts to more complex problems. This one was about another property. So multiplication is commutative, but division is not. But again, from a sense-making point of view, this was an equal sharing problem that pupils had. 5 classes have to share 3 bottles of juice, and this was their drawing for it. The purpose of this wasn't to explore this, but I've used the drawing to kind of illustrate what you might get pupils to do. This pupil wasn't at the stage of recording this as an equation, but if they were, you could use that to then pose a similar problem, but where the numbers were reversed, to show, using the pupil's drawings, why 3 divided by 5 is not the same as 5 divided by 3, other than just telling them that it's not the case. Incidentally, this is a P5 pupil, and that's perfectly accessible at P5, and then moving on to these types of things into sort of P6 and P7. Then you might kind of start to pose these more abstract problems once pupils have explored it through making sense with those story problems and their drawings. And again, getting them to justify their answer, explain to someone who hasn't been able to make sense of that. So final couple of minutes, I just want to look at that kind of longer term retention. I would say that for many pupils, this isn't necessary. They'll start, if you do all of those things that we've kind of mentioned there before, and they've got really rich experiences, they will just start to learn multiplication and division facts and things like that, and they'll start to apply them too. But for pupils that struggle, you might set up something like this. It's an adaptation of the Leitner system, which uses spaced repetition. I want to emphasize that I would only use this with pupils that have gone through that process of making sense and developing fluency. So when pupils are confident with a set of facts, they might make their own flashcard for it. So an expression or an equation on the front with the answer on the back. Include a variety of problems, missing numbers, inverse operations, equal sign in different positions. And then the pupils test themselves either daily, weekly, monthly. And so as they become more confident, as a fact it becomes knowledge, they move it to the next box. And then if they're less confident or they've forgotten it, then it moves back a box. So they keep practicing these things until they've retained them. That could also be used with sort of card games and things like that. So now it would be appropriate to use these more abstract things once pupils have understand it and gone through all those other experiences as well. And that might be to build basic facts, mathematical language, notation, and so on. And then finally, that could be introduced into kind of lessons of starters, homework, or interleaved into new areas of learning, again, building on the skills learned in previous sessions. So I rushed that last bit a little bit. I'm sorry about that, but hopefully you can see it in more detail afterwards. But just to summarize, we've looked at what's our starting point. I really want people to kind of consider that. Have we built those strong foundations? Have we made sense of what's going on? And then have we provided opportunities to develop fluency, support retention, and then move into that long-term learning and application, but with an understanding that this is quite a fluid process with multiple kind of levels going on at any one time. So that's me. I hope you enjoyed it.